a table of stuff that we talked about, right? So the classical probability, right? Rolling dice, right? Boom. That type of thing. This a classical probability. These empirical probabilities are where we're looking at a table, right? And we have frequency of number of outcomes over total outcomes, right? So so the difference would be, right, you're given like a situation you got to figure out, and then with the empirical probability, you're given like a table of values. You got to figure out a probability based on stuff that's happened in the past, right? We got a rule that tells us that, right, probabilities are always between 0 and 1. So we also have our complement rule, right? Don't forget, right? The probability something does not happen, usually you got to subtract from 1. Okay, so if you see the word not, think maybe I need to subtract from 1. We got our multiplication rule, which we talked about in 3.2, and our addition rule. Just a little summary of the probability that we've done, because once we're done with this lesson, I taught you all the probability, at least the theoretical probability that we're going to look at for the course, and then we'll be able to use it. And then the other probabilities that we'll look at will be probabilities based on normal distributions. Good stuff. All right, so let's find the probability that this donor has type B blood or is Rh negative. First of all, let's decide, are these two events mutually exclusive? And if it is the case that there are individuals who have both type B blood and are Rh negative, then they are not. Then these two things are not mutually exclusive. So if we can find that on this table, then that will be the case. So Rh blood and type B blood and Rh negative and type B blood, there are 8 of those actually. Okay? So these two events that are not mutually exclusive, which means that I'm going to have to use the formula that says that the probability of A or B is going to be equal to the probability of A plus the probability of B minus the probability of A and B. Let's do that. So it's going to look like this. They're not mutually exclusive. Oh, look at that. I'm going to go ahead and write it here. So, probability A or B is equal to the probability of A plus the probability of B minus the probability of A and the B, which in this case is going to be, okay, so the probability that a person has type B blood. So all of these people, right, this is the total right here of people that have type B blood. And here's our total possibilities. So that's going to be 45 over 409. Plus the probability that they're Rh negative. Where are our Rh negative? All of our Rh negative people are over here, right? And that's going to be over 409. So 65 over 409 minus the probability of A and B, which is this guy that we pointed out before, right? Which is now going to be 8 over 409. And I believe that has not been calculated. Have we not even? Okay, cool. Fantastic. Let's calculate it. That is going to be equal to 45 divided by 409 plus 65 divided by And I could have saved myself a whole lot of time and just put those all in my numerator, right? Okay, approximately. Oh, let me get my pen back. So approximately 0.25. So you anticipate it happening about a quarter of the time. That's what I think might happen. Alright? I'll hit the pause button and then we'll move on. Oh, and there's the solution. Well, there it is. That's what we did. Hey, what is the probability that a randomly selected draft pick is not a linebacker, nor is it a quarterback? All right. They are. Yeah. There's not a. It doesn't look like anybody shares anything. Yeah.
I don't think you would be a quarterback linebacker.
That'd be weird. Yeah. Okay. So, first of all, I would really like to know the total, right? And actually, let's go ahead and look at this slide. No, it doesn't have the answer. Fantastic. That's good. So confused. Sometimes they're All right, let's get a total here. Well, that's why I wanted that. I wanted a total. 256. Right. So if you add this up, our total is going to add to 256. Just trying to save some time on the calculator. All right. So not a linebacker or a quarterback, right? That's everything else, right? Yeah. So essentially, right? Isn't it the probability that it is? Isn't that 1 minus, right? Everything else 1 minus the probability.
About 220 over 256.
Let's go probability A or B. We've determined that these two things are not mutually exclusive, so that's going to be 1 minus the probability of A plus the probability of B, where A is probability it's a linebacker, or probability that it's probability B is the probability that it is a quarterback, right? So the probability that it is a quarterback is 12 out of 256. Sorry, it's a little janky there. Alright, and the probability that it is a linebacker is 24 out of 256. So that's going to be 1 minus, and that is going to be 36 out of 256. Let's go ahead and put that in our handy dandy calculating machine device. 1 minus 36. That is approximately 0.8. Let's just go 0.86. You could do that as well. That would work. Totally. You could add up all the things that are not quarterback or linebacker there, right? And then do that division as well. That would totally work. 2 ways to do that. All right. So that is what we did. That is what you'll do right there.